motor is a three-phase motor. It just takes industrial electricity to run it. Three-phase power. Most of them have single-phase power, which is two wires, power, and ground. So on the VFD, we have power wires in, and we have motor wiring out, right here on the face. You want to verify if you're using 230 volts, that this VFD is rated for 230 volts, and it's rated for 200 to 240 volts, so we're good. The first thing we want to do is hook the VFD to the motor. That's on terminals U, V, and W. Oh, I've got some wire here. You're going to need conduit, and you're going to need or a cable like this. But I'm just going to use wires to make it easy to see what's going on. So you need 3 wires for your motor plus a ground. It's important to know that these U, V, and W go to the motor. If you accidentally hook power to U, V, or W, you will blow this up and it will be a brick that you could throw in the dumpster. So these wires go to the motor. Each motor has a wiring diagram. The wiring diagram shows how it's to be hooked up for low voltage or high voltage. This motor is rated at 230, 480. That means we need low voltage if we run it on 230 volts.
If we're using 240 volt, which we are today, we'll want to hook 4, 5, and 6 together. We'll want to hook 7, 1, and line, which is our power line, together. 6, 2, and line. 9, 3, and line. Actually, that's right, it's 8, 2, and line. So just follow that diagram. And each motor is going to have its own diagram, probably in this lid, or maybe on the motor. But that diagram will be on every motor.
Okay, so now we've got the 3-phase power coming out of the VFD drive that's going to go to the motor. The motor, this motor, has come with ring terminals, which is a kind of a European thing. We're probably not going to use those. As we know, each motor has a number on it, and that number is very important. We don't want to lose that while we do our wiring. So I'm going to slide these numbers up so they don't fall off, so that we don't get confused as to what each wire used to be. And then we're going to cut off each ring terminal that we don't need, and we're going to strip the leads. If your electrician wants to use those ring terminals, they certainly can. I just like to use wire nuts. Okay, next we remove the conduit hole plug so that we can add the wires in through there. Again, you're going to want to make this up to code. You're going to want this in a conduit or with a cord. So we're just doing a demonstration, so we're not going to use either. It's easier to see this way. Now we've also got the ground wire we need to install. There's a ground lug here on the left. In this case, it's an Allen wrench to adjust that or loosen that, tighten that. So we want to get the ground wire under the pressure point. So that's a wired motor for 3-phase power. We coil these up carefully. Make sure that they don't get pinched. None of these wires can be pinched under this cover. It's a real common thing to accidentally happen. And we want to put the cover back on. Now we've got our VFD wired to our motor, and that's all looking good. 4 wires. 3 for power, 1 for each phase, 3-phase on U, V, and W. Ground for the motor on the ground terminal. Now, we need to apply power to the drive. I have control of the plug, so I know it's not hot. I'm going to attach these to terminals L1 and L2. Since we're not using three-phase, there will be nothing attached to L3. So it doesn't matter white or black because both of these are power. There is no neutral. We need 240 single phase. Okay, tug test on all three looks good. Our power is connected. We need to install a jumper between 1 and 2. We need this jumper to go from 1 to 2. So now we've got single phase power going to a 3-phase converting drive, VFD, 3-phase power going to our motor. It's not a good idea to be anywhere near them. So we'll step away. Now we should have power. It'll teach you how to change parameters, and it will also teach you what the parameters are. So what we want to do is set the maximum frequency to 90, the minimum frequency to 10. So let's do those. So we'll hit that button, we'll hit stop, then we'll hit this button. Got to hold that for 2 seconds. There's parameter 1. That's the one we want. It's at 60. We want to take it to 90 hertz. There's 90. So now parameter 1 is 90. Now we go to parameter 2. It's at 0. We want it to be 10. Parameter 2 is now at 10. The next one is probably the most important parameter, and that is setting the nameplate amperage. So this motor at 240 volts, 60 hertz, is 12.3 amps. 12.3 amps. So we got to figure out which parameter is motor current. Motor rated current is parameter 8. 12.3. This is the most important one, and it has to match what's printed on the motor. This protects your motor from burning up if it gets overloaded. So we got to find how many it's rated at. Type that into here.
12 goes to 1. Hold it for 2 seconds.
So if I hold that for 2 seconds, it takes me back out. All right, so we programmed the drive. Now we're ready to run the mill. So we've got a single phase power coming into here. On L1 and L2, we're using ground. Our output, we've got a ground for the motor. UV and W go to the motor. All three are required. We've wired the motor per the motor diagram, and we've installed the jumper between number 1 and number 2, and we've set all 4 parameters. We set parameter 1 to 90 hertz max speed, parameter 2 to 10 hertz minimum speed. We set parameter 8 to motor frequency, and we set parameter 12 to keypad control. That lets the keypad run the drive. So now we can hit start. Drive run. That's 10 hertz.